Give me a thumbs up when you're ready for the title. Ten. So again, a thumbs up when you're ready for the title. 12. And in case you didn't hear me the first 2 times, give me a thumbs up when you're ready for the title. 13, 14, 15, 16. All right, I think that was everyone now. So the title of this one is glitchy again today. All right, I guess we're being laggy today. 4.3, right triangle trigonometry. So using the unit circle again, and then also incorporating triangles. We're going to be putting those 2 things together and finding all the trig values. So 4.3, right triangle trig, or right triangle trigonometry, if you want to write the whole word. It's a really long word though. In case you didn't get my email, Mr. Q volunteered. He doesn't get a lot of students coming into his tutoring because he teaches all IM1, and freshmen notoriously don't really care about their grades. So if you check your email, you guys are welcome to go to his tutoring time. Like if mine is full, or maybe you just don't want to come to mine, you can go to his. Cool. Cool. I shared his Zoom link with you via email if you ever want to go into his tutoring times, because usually he doesn't get like any students at all. So I'm sure he would greatly appreciate seeing you guys again, and also doing something other than IM1 content, and also not sitting there bored. All right. So our first key concept is reviewing that sine, cosine, tangent that you should have learned last year and what those mean on a triangle. And then also talking about cosecant, secant, and cotangent. Remember that those 3 are the opposites, or the reciprocals of sine, cosine, and tangent. So when we're talking about opposite, we're talking about wherever this angle is. So that angle we call theta, so theta. Opposite of that and adjacent to that, and then our hypotenuse is always our diagonal side or the longest side. So when we're talking about opposite and adjacent, it's referenced to that angle specifically. Cool. Give me a ta-da when you wrote down everything you needed. You wrote it down that fast? You did not. You just remembered it, huh? Okay. I mean, once you remember like the first 3, I think you probably already know the first 3, and then the other 3 I just flipped over. So like, no biggie. Also, one easy way to remember the difference between these 2, this is how I remember it. The word cosine is C-O-S, and then secant is almost spelled the same thing but backwards. So then you can remember that those 2 together, and then cosecant is just the one that's basically trashed, so it's just left over. Obviously goes with sine. Does that make sense? Yeah, okay. So again, give me a ta-da when you're ready to move on. You wrote down everything you needed to write down. I got about 7 so far. And there are a lot of questions on your homework. However, the first 6 questions are Sine theta equals what? Cosecant theta equals what? So the first 6 questions are based on those 6 properties. So by all means, if you want to do your homework at the same time, you're welcome to. Good, Quade. Your other class is probably going to pass this class up though. Like they're going to be lined up for now and then they're probably going to pass us because this is a year long and that one's only a semester. Got about 12 ta-das, I think. But I see a few of you still writing, so no worries. No rush. Couple people still writing. Just waiting patiently. All right. I think that was everyone, I think. Dwayne, are you still writing?
I just got done.
Okay. I just looked up and I saw that you were writing still. All right. So using those, first we're going to talk about the 3 special triangles. And by special, they're very commonly used. Well, there's 2 special right triangles. This one's just commonly used. So say we're given a triangle and it only has 2 sides. We have to find the 3rd side. Hopefully by this point, you know about Pythagorean theorem, and that tells us what the 3rd side is in a right triangle. Are we okay there? Okay. So in this case, we're finding the 3rd side or the hypotenuse. So I'll just call that side h for now. So we would say that h squared equals 3 squared plus 4 squared. So if we're not given the 3rd side, we have to use Pythagorean theorem to find the 3rd side. Or maybe you already know what the 3rd side is because you recognize this triangle. I don't know. If we simplify that, that gives us h squared equals 9 plus 16, or h squared equals 25. What number squared gives you 25?
5.
5. So we are going to say that our hypotenuse is 5 in this case. So now we have the opposite, the adjacent, and the hypotenuse, and we're going to find all the 6 trig values. So sine, theta, cosine, let me write those further apart. Cosine theta and tangent theta. So sine is opposite over hypotenuse. So from that theta, opposite is 4 and our hypotenuse is 5. Cosine is adjacent. So adjacent meaning next to. So that one's going to be 3 over 5. And then tangent is opposite over adjacent. So that one's going to be 4 over 3. Are we okay with those 3? Okay. And then we have cosecant, secant, and cotangent, which are essentially just the first 3 flipped over. So we had 4 over 5 for sine. So cosecant is going to be 5 over 4. We had 3 over 5 for cosine. So secant is going to be 5 over 3. And then we had 4 over 3 for tangent. So cotangent is going to be 3 over 4. Not too bad? Not too crazy, right? Okay. Let me know when you are ready for example 2. Not yet. Kiana's like, nope. So on your homework, there's a question like this where it'll give you the triangle. You'll have to find the 3rd side. And then once you find the 3rd side, you're just listing what the ratios are. Let's go with a blackout when you are ready for example 2. Or a color out. Or a favorite picture out. I don't know. Is that a giant eraser? Oh, it looked like a giant eraser, I guess, just because you're putting it close to the camera. Aiden, have you been waiting for this moment? You seem too prepared for that.
I drew this amazing picture.
I love it. All right, I think that was everyone. We will go ahead and move on to example 2. So in example 2, this is a 45, 45, 90 triangle. This is one of the special right triangles. So when we have that special right triangle, it looks the same. If, for example, if this side was 5, then these would be just 5 in front. But in this case, they're going to be 1. So definitely remember the special triangles. You can literally Google special right triangles, and there are 2 of them that pop up. One of them is 45, 45, 90. The other is 30, 60, 90, which is the next example. So all 3 sides are already filled in. So for us to find sine, cosine, and tangent, those should be easy for us to find, right? Right? Say right. Okay. So I'm writing with an eraser. Sine 45 degrees, cosine 45 degrees, and tangent of 45 degrees. So remember, sine is opposite over hypotenuse. So it doesn't matter which opposite side we use because notice that those are the same. So opposite of 45, we're going to get square root of 2 over 2. And then our hypotenuse is 1. If we simplify that, it's just square root of 2 over 2. You might notice from your unit circle or from the table, the trig table, that this is the same value for sine of 45. It's always going to be square root of 2 over 2. Cosine is going to be the same thing because we have the adjacent side. We have 2 45-degree angles, but the adjacent side is the same no matter what. Oops. So our adjacent side is square root of 2 over 2, and our hypotenuse is 1. And then again, if we simplify that, it's just square root of 2 over 2. And then for tangent, we're going to use opposite over adjacent. So square root of 2 over 2 over square root of 2 over 2. If I divide something by what it is, then the answer is just 1. So I divided square root of 2 over 2 by square root of 2 over 2, so it's just 1. Cool? Those values for sine, cosine, and tangent of 45 will always be the same. Always. Don't forget them. They're on the trig table though. Give me a, I don't know, which reaction should we use? Let's go. Surprised reaction when you were ready for example 3. Look at that. We're so ready. Got 4 more, 3 more.
Reaction.
What?
Don't you mean open mouth reaction?
I hate calling it that. No, I mean the surprise reaction. Stop calling it the open mouth reaction. That just sounds so, never mind. I'm not even gonna get started on it. But no, I'm gonna keep calling it. It's a good drawing, right, Liam? Like, didn't it seem like he was prepared for me to call blackout earlier? Yeah, I think he was. All right, so in this one, again, this is the other special right triangle, so a 30, 60, 90 triangle. When we have 30, 60, 90, those ratios are going to be the same, and those are the same values that we find on the unit circle. So 1/2 and square root of 3 over 2, and we have a radius of 1. That's where the unit circle comes from. So that triangle is drawn already for us. So this is supposed to say, what? I clearly messed up when I was typing this. This should say sine, cosine, and tangent. Not sure what happened to my typing skills there. So sine, cosine, and tangent, this time 60 is our reference angle. So we're talking about adjacent and opposite of 60. So sine 60, cosine 60, 60, and tangent of 60. So just like before, sine is opposite over hypotenuse. So we're talking about opposite of 60. So square root of 3 over 2 over the hypotenuse, which is 1. Since we're just dividing by 1, whenever we simplify that, it's just going to be the square root of 3 over 2. And again, these match the same trig values that you have on your unit circle. If you looked up sine of 60 degrees, it would be square root of 3 over 2. Cosine of 60 degrees, so we're talking about adjacent over hypotenuse. So 1/2 over 1. If we simplify that, it's just 1/2. And tangent of 60 degrees is sine over cosine, or opposite over adjacent. So square root of 3 over 2 over 1/2. In this case, the 2's are going to cancel each other out. So that leaves us with the square root of 3 if we simplify it. Do we have any questions? No? Not too crazy? Cool. Give me a heart when you're ready to move on. I still think that's my favorite one. Except for when you guys don't give me the heart reaction and it's just blank. And then I just have to sit here unloved. See, Quaid? There you go. Unloved. Rude. None. None at all. Liam, are you still writing? Okay. Aiden, did you hold it up close enough so that everyone could see it, like in detail?
Yeah, so I'll break down what's happening right now, okay? So
You have to hold it close.
we have old Major right here, all right? And he's an allegory for Karl Marx. That's why he has the red star, okay? And then he's playing guitar because he's singing Beast of England, and he's saying beast, but it's misspelled. And then this is a chicken/horse watching him.
A chicken/horse?
Yeah, I meant to draw a horse, but it looks like a chicken, so it's a chicken now.
Okay.
They're also communists.
I thought you made up like a character and I was like, what is a chicken/horse? But okay. All right. Nice. Beautiful. All right. We're moving on. Our next key concept is just reviewing that sine, cosine, and tangent for those special right triangles. These are directly from your unit circle. So I'm not going to leave them up for you to write down because you already have them on that unit circle table from earlier. And then when we're talking about complementary angles, when we talked about complementary angles earlier, complementary just means that they add up to be 90. So if I have cosine of an angle, I could do sine of 90 minus the same angle. You're not super likely to use those complementary angles because you're probably just going to go find it on the unit circle. Does that make sense? So they're there, but you're probably never going to use them because it's more work than just doing the angle in the first place. Cool? So I'm not going to leave it up there for sine, cosine, and tangent. Those are directly from your unit circle. Hopefully you have the link to the unit circle table, if not, or the trig table. If not, let me know and I will share it with you. Okay. Using a calculator. I'm pretty sure you need this calculator. I don't think it works on Desmos. But somebody try it on Desmos and let me know. So when we're typing these in, just because they do show up, whenever we're talking about the real world, we talk about angles in degrees, minutes, and seconds. And that's like just a very specific way of giving a degree measure instead of giving a decimal for a degree. So we can actually type those into our calculator. So we can type in cosine. So like literally the cosine button, right? I'll write it down. Cosine button. Then we're going to press 5. Then we're going to press, where's the degree button? I lost it from last time. Oh, quit. I just did this earlier because I was like, I need to make sure I know where the degree button is. Now I don't remember where the degree button is. Nope, it's not there. Dang it. I'm going to find the degree button, guys. I know. when I saw this in the lesson, I was like, I need to figure out where that is because I don't think I've ever typed in the degree button on the calculator. And I found it. Oh, there's an angle menu. That's where. Okay. So we have cosine 5. Then we're going to press the second button. Then we're going to press the apps button. And then we're going to press option number 1, which is an angle. So far, so good. We're not done typing it. Then we're going to type in 40. Then we're going to type in the second button again. Then apps again. And we're going to go down to option 2, which is an apostrophe, but we're going to call it minutes. Then we're going to type in 12. And then we're going to press the alpha button. Then we're going to press the plus sign. And that will give us seconds. And then press enter. Tell me what you got for cosine of 5 degrees at 40 minutes and 12 seconds. Type it in the chat. It doesn't have to be private. Just tell me what you got. Because then I can quickly tell if you remembered to put it in degrees or radians. Quaid and Ella, are your calculators in degrees or radians? So click mode at the top and change it to degrees. And then you can go back up and select where you typed that in earlier and just press enter so that you don't have to type it again. That is correct. Give me your answers. You have to do this on a calculator. There is no other way. You could try it on the Desmos calculator or you can use this calculator. Kiana, you are correct. Ella, that's correct. Somebody else answered me earlier. Only have 4 answers. Diego, you're correct. Whoa. Isabella and Israel, make sure your calculators are in degrees.
Are we supposed to round it?
Yeah, just do like 2 or 3 decimal places. Oh, the apps button is right here. So like next to math, there's the apps button. And if you're getting 0.818, then your answer or then your calculator is in radians. So at the top, way up here, it should say degree. If it says rad or radians, you need to change it. So you'll press mode. Then you'll change the third one. Yeah, the third one to radians or to degrees, sorry, and press enter. And then you can go back up to where you typed this in earlier and just press enter twice and it'll calculate it again. You should have an answer now because I just gave you the answer like 4 times, but we should have gotten an answer of 0.995 approximately. If you got 818, make sure your calculator is in degrees. Calculator is in degrees. Cool. You might be able to do that on the Desmos scientific calculator. I haven't tried it, but just in case I wanted you to use this calculator. Are you ready to move on? Okay. Here are some other questions that show up on your homework. It'll say sine theta is equal to 1 over, and you have to type in cosecant theta. Let me explain what this says. We already know from earlier that sine and cosecant are opposites of one another. That's all the reciprocal identities are saying, that they are opposites of one another. The quotient identities, that's just defining what tangent and what cotangent are in terms of sine and cosine. So tangent is sine over cosine, cotangent is the opposite of that, or cosine over sine, And the last three are brand new, so definitely write those ones down. I added in some extra definitions over here because I hate the way that the book writes them with, I want them all to equal 1. Cool. So definitely write down these ones. The other ones you already know, they're just written in a different way. We already know sine and cosecant are opposites of one another. We already know cosine and secant are opposites of one another, and we already know tangent and cotangent are opposites. Give me a, let's go with a crying, laughing. We haven't used that one in a while. What's it called? Joy? Let's go. Give me joy when you're ready to move on. That sounds weird. So I got about 7 so far. Wait, is it actually called a crying, laughing emoji? Yeah, no. I call it a crying, laughing emoji, but I don't know why. Doesn't Zoom call it joy?
Zoom refers to it as that.
Yeah, no. I only refer to it as joy because that's what Zoom says it is.
My best bet is it's like to get around like copyright or something.
Maybe that's why they don't use the surprise. Instead, they use open mouth because that
It
just
would
sounds
be
weird.
like, wouldn't it still be copyright because it's the exact emoji?
It depends on like how it's copyrighted or whatever.
Maybe the code is copywritten, so they have to change the name in the code. I don't know.
And
Now you know what joy
it
is,
could be
right?
very small differences that aren't really like enough to like really notice or like whatever.
Just enough to not get sued. Got it.
A list of things.
All right. Are you guys ready for this? It's not that bad. So we have that cosine of theta 0.8. So I'm going to rewrite that as cosine theta is 0.8 over 1. Because I know that cosine is opposite over or adjacent over hypotenuse. Are you with me still? Great. Now we have to draw a triangle, a right triangle to be exact. And you're going to put theta somewhere. Could be in either angle. I'm just going to use the bottom one. So I know that the adjacent side is 0.8, and I know that the hypotenuse is 1 because that's what the information told me.
Can we have time to write down the
Yeah.
problem?
Yeah. Do you want me to erase this so you could see? Anna got disconnected. There we go. While you're rewriting it, I'm going to draw a better triangle. Because that one was ugly. Okay, I like that one better. Oh, 0.8 and 1. So from here, how do we find the missing side? Not everyone at once.
Subtract the hypotenuse or square
Not
it.
subtract. Yeah, square it. So we have to use Pythagorean theorem. So we'll just call this x for now. So we can say x squared plus 0.8 squared equals 1 squared. So the 2 legs squared equals the hypotenuse squared. If we do all that on the calculator, we get x squared plus 0.64 equals 1. And then we can subtract 0.64 from both sides. So x squared equals 0.36. Yeah. And we can take the square root, which gives us 0.6. So now we know all three sides of the triangle, and we can find sine of theta and tangent of theta because the triangle is already drawn. I'll give you some time to catch up because I know I'll answer that question super fast. And if you're already caught up, then find sine of theta and tangent of theta. Ugh. There we go. Are you ready for him? Yeah? No? Okay. I saw too many no's. If you are ready for them, go ahead and try to find sine and tangent. So remember, sine is opposite over hypotenuse, and tangent is opposite over adjacent. I'll give you one more minute. So at 2:23. Who's there? It's not 2:23 yet. Don't worry. I have like maybe 30 seconds. This is the longest minute ever. Oh, thank God. So sine of theta is opposite over hypotenuse. So opposite of where theta is 0.6, and our hypotenuse is 1. So we would just simplify that to be 0.6. No, cosine was 0.8. And then for tangent theta, it's opposite over adjacent, so 0.6 over 0.8. If we do that on a calculator, 0.6 divided by 0.8 is 0.75. Cool? Okay, so anytime we're talking about opposite and adjacent, you're talking about from this angle, wherever you see theta, it's opposite of that and adjacent to that. So if theta is up here, then it's opposite of that and adjacent to that. Cool? Cool, cool. Okay, give me a ta-da when you are ready to move on. That was fast. I was not thinking that many people would be ready to move on that quickly. 3 more. Give me a ta-da when you are ready to move on. All right. I think that was everyone. This, for example 6, it's very similar to the example we just did. So I'm not gonna go through it as slowly, but we can still go through it. So we have tangent of, why am I writing with the highlighter? We have tangent of theta equals 3, but I want to write it as a fraction because all of these are ratios. So I'm just going to put it over 1 because now I know that this is my opposite side and this is my adjacent side because tangent is opposite over adjacent. So we'll go ahead and draw our triangle. We'll add theta. If you're already to this point, go ahead and try to find cotangent theta and secant theta. I know some of you are still writing down the question. I don't want to rush you too much. So they gave us tangent 3. We put it over 1 just so that we have 2 of the sides. We'll put those on the triangle. We'll use Pythagorean theorem to find the missing side, and then we'll write our ratios. All right, most of you look ready now. So I put theta on the triangle. Opposite of that is going to be 3. Adjacent to that is going to be 1. And then we'll find our missing side. So I'm just going to call it x. You can put whatever letter you want. So x squared equals 3 squared plus 1 squared. So the hypotenuse squared equals the 2 sides squared. Or x squared equals 9 plus 1, which is 10. Those are ugly too. And then we'll take the square root of that. Since we don't know the square root of 10, we'll just leave it as the square root of 10. And that's totally okay to leave it as a square root. So cotangent is the opposite of tangent. So adjacent over opposite. Sorry, I'm confusing myself. So 1 over 3. And then secant is 1 over cosine, or hypotenuse over adjacent. So square root of 10 over 1, which is just the square root of 10. And some of you had that in the chat already. Well, Luis, you had that in the chat already. You were right. Cool. So they give you the information about the triangle. You're going to change it into a fraction by putting it over 1. You're going to draw the triangle, use Pythagorean theorem to find the missing side, and then fill out your whatever trig values they ask for. One more example. Are you ready for it? It's pretty quick. All right. I don't see anyone still writing, so I'm going to move on. All right, last example. So these are just using those trig identities that we talked about earlier to show different proofs. There's 1 or 2 like this on your homework, but just to get you practice with them, because you'll have to use them a lot whenever you take calculus in simplifying some of the expressions. So cosine times secant, we want to prove that that equals 1. The easiest way to do that is we know that secant is 1 over cosine, right? So we can change secant to be 1 over cosine. If we multiply that out, we would have cosine over cosine, which we know equals 1. So there we go, we proved it. Not too bad, right? Okay, proved. Next one, if we multiply those out, I'm going to multiply them using box method. So secant theta, tangent theta, secant theta, and negative tangent theta. I'm going to make this box bigger. There we go. Tangent theta. So if we multiply secant times secant, that's just secant squared theta. Secant times tangent is just secant tangent. So secant theta, tangent theta. Secant times negative tangent is negative secant theta, tangent theta. And then tangent times negative tangent is negative tangent squared theta. If we write all of that out, we have secant squared theta plus secant tangent minus secant tangent minus tangent squared theta. The two middle terms are opposites of one another, so they cancel each other out. And we're just left with secant squared theta minus tangent squared theta from our Pythagorean identities earlier, we know that that equals 1. So those are just using those Pythagorean identities and using those trig identities to simplify these expressions so that you can prove that one side equals the other side. And that is our last example. So